Live from New York, it's Ask an Engineer.
Hey everybody, welcome to another fantastic Ask an Engineer. We have a full cast in town today. Woz the Wozniak, and Becky, and me, Lady Ada the Engineer. We're going to have a lot of fun stuff to show off today, talk about engineering, answer questions, maybe even some news. We're going to open up a beer. Oh, here, let me do that. That's how we, that's our ceremonial.
If you give me a lever long enough and a fulcrum on which to place it, I can move the world and or open a beer.
Or just a stainless steel ring.
Yeah.
We got so much stuff going on. Tell them what's on today's show.
Okay, on tonight's show, the code is Bento. 10% off many kits, including a new kit we're calling Bento. 10% off, Bento. We're going to talk about the show and tell. Some amazing people showed up some cool stuff. We're going to have some new products, like the Python badge, some diodes, some transistors, a new SD card, some glands. That's right, we're in the gland biz now.
Glands.
We've got
Glands.
wires, all sorts of different hookup wires for breadboards. We've got a Bluetooth extension cord. Yeah, I haven't slept.
Bluetooth control power cord.
Yeah, and then we have a level shifter. We're gonna answer your questions. We have a trivia question. We're having a cat. All that and more on Ask an Engineer. Okay. Whew.
Yeah, that's a lot.
I'll stumble through
That's
this.
a lot to cover through,
Okay,
but
so
I think we can do it.
you've got a beer.
I've got a beer.
You're here on the weekend. We're wearing our ceremonial transistor t-shirts.
Oh yeah, maybe you can stand up real quick.
Mine
So-
you can't see because mine's reflective.
Yeah.
So
This
thanks, Transistor.
Beta of the transistor.
Yeah,
t-shirt.
we got official permission
Hi,
from
Beta.
Cambridge Press and Horowitz, one of the authors of the book, to make these shirts. These are just us testing. You have a reflective version.
It doesn't show up.
Yeah,
It's
but look,
blinding.
yeah, but look how
It's
reflective that is.
it's
It looks
super
like it's
reflective.
glowing. It looks like a neon
We didn't
panel.
realize it would be that reflective.
Safety first.
Yeah.
Well,
Always tie down those gates.
safety somewhere in the top third.
Yeah.
Yeah.
Maybe third.
And Becky's here.
I don't have a transistor shirt yet.
That's okay. Well, you didn't show up. You know, we had like 3 shirts, and then
We had to
you had to
coordinate.
fight over them, and then you weren't here. We'll get you one
Those
soon.
shirt looks good.
Yeah, I got you.
You also don't
Yeah.
seem to. You don't wear black that much.
Are you kidding?
Really?
Yeah.
Okay.
It's because she normally has a shawl, a multicolored shawl.
Oh yeah, you have.
You usually have
something
some
over.
shawl action.
Accessorizing.
Shawl.
You guys have nice
I like the
clothing.
mental picture of my wardrobe, you guys. have.
Shawl.
No, I wear black t-shirts all the time.
Yeah.
It's a secret for people who sweat a lot.
Okay. We'll get you a black transistor t-shirt.
If you have sweaty wearable electronics issues, it's okay. We've got glands.
Glands.
Okay,
We'll
so
discuss glands shortly.
let's kick this off because you guys are going to talk a bunch, and Waz is going to talk fast. Tonight's code is Bento. 10% off most and many things in the Adafruit store that we make. So use the code Bento. We'll go over a couple more times. Let's start off. We had a show and tell. Try to remember what are some of the things that were on the show and tell.
What?
Okay, so things that were on the show and tell were someone who was making a quilt that used a soft circuit based on something that Jerry Ellsworth did that basically did a cascade counter, and he wanted to make an interactive art project that people could sort of jump around all the patterns on the quilt. Then someone else was doing continuing work on making a GPS controller for a helicopter that could be dual purpose for a high altitude balloon, which was particularly awesome. He'd finally gotten past the smoke test, where you power it up and pray that you don't blow it up, which is a critical turning point, so that's great. Someone was working on basically a ham radio to internet portal. He was making a device that does it. Apparently there's a lot of infrastructure already. The Charlie Cube was shown. Then there was
Helicopter from
No,
Ethan?
I talked about Ethan's helicopter.
The
Oh,
internet
someone
mood
had
box.
the internet mood box where you can log into
Yeah,
his
that's
web
good.
server and set the mood in his room.
Yeah.
I like thunderstorms.
And
Yeah,
then Harry
Thunderstorms is
had
pretty
his
good.
analog thing that he was.
There was an
showing.
analog counter,
Yeah.
along with or an old TTL-based
Yeah.
counter.
I
Built
think it was
out
TTL. I
of-
think it was
No,
CMOS.
it was TTL built out of D flip-flops. He was
Okay.
using the 74HC series, and then
74HC is not TTL. It's
yeah, it's
CMOS.
TTL. No, TTL is like the CMOS is the chip infrastructure, and TTL is the logic level communication interface.
Okay.
It's already on. It's on.
TTL
I
is like the
Round
input
one.
output.
I always think of it as like transistor.
Step aside.
I mean, it used to be, but then TTL is sort of what the 74HC series. It's like the input output spec.
So we just
on the
say
wire.
that. We just
Yeah, we just say TTL now. It's like TTL style logic or TTL interface logic or whatever. And then I know I'm forgetting a couple of things, but
A bird showed up.
Oh yeah, the guy who does the ham radio stuff has a kayik, just like Fuzzy, which I'm very excited about. Now I know that they sound the same.
We like pets and electronics. Okay.
But they
I
don't
just like
work for
poking you
chewing on
about
it.
TTL logic. It's
Yeah,
fun.
TTL. I'm so TTL too, you can't stop. So yeah, it was good.
It was a full house. It was a pretty full show and tell.
Yeah, it was all really good. It was all really nice to watch.
Yeah. All right.
What do you do?
How do you get on the show and tell?
To get on the show and tell, all you have to do is add yourself to the circle. And to do that, you have to post a comment on my personal Lady Ada Google Plus feed. Whenever I say, hey, post here to get added to the circle, and we add you to the circle, and the next time we have show and tell, you get invited automatically. If you're not in the circle, you won't see the invitation, so you have to do that ahead of time. So if you ever plan on showing off anything, just do it now, get it over with, add you, and then it's easy to join whenever you want.
Okay. Next up, we're just going to dive right into the new products because we don't have a lot of time, and Waz is going to drop some knowledge on everybody. New products. The first thing we're going to do, actually, Becky, can you set this one up? This is the video you did for the fingerprint scanner. Do you want to talk about this video you made?
Sure. I made a video about how to get started with the fingerprint sensor. It goes along with the photo tutorial, so it's just like a good video overview because the process for enrolling your fingers is kind of involved.
It's a little weird. You have to do a couple things.
And then for this, you use the straight-up Arduino enrollment because you don't have a PC.
Yeah, I don't have a PC, so I couldn't run that fancy software. So if you have a PC, you could run the fancy software, but I used the like you put one sketch on the just roll.
Yeah, rotate.
Yeah. Okay.
Yeah.
Here it is.
Today we'll be getting started with the fingerprint sensor from Adafruit. It's easy to incorporate into your Arduino projects.
Yeah.
To get started, hook up all 4 wires to your favorite solderless breadboard and connect power and ground. Next, hook up the green and white wires to digital pins 2 and 3 on your Arduino board. Lady Ada has written a special library for the fingerprint sensor, which you can download from the Adafruit GitHub repository. Once you've got your library loaded up, open the Enroll sketch from the samples and load it onto your board. This will help you register your fingerprints with the sensor. Open the serial monitor and follow the prompts to enroll your fingerprints. It'll ask you for a numerical ID and then ask you to place your finger, remove your finger, and then place it one more time so it knows it's got the right image. If it doesn't work the first time, don't be discouraged. Just keep trying. It needs to get a clear picture both times you place your finger to be sure it's got the right print. Continue enrolling until you've got all the fingers you want stored in the sensor. Then open up the fingerprint sketch from the examples folder. We can add just a few lines of code to light up some LEDs. Here I've set pins 11 and 12 as outputs, and 12 is my red LED, which I'll set high on from the start. Then find the bit of code where it found a match, and add some extra code to turn off the red LED, turn the green LED on for a moment, then turn it off and turn the red LED back on, indicating we've got a match. Load this code onto your Arduino board, and open the serial monitor to verify that your sensor is actually reading your fingerprints correctly. It'll give you a confidence measurement for how sure it is that it's a match. The higher the number, the better the match. Wire your LEDs to reflect what you wrote in the code. Mine are connected to pins 11 and 12. Now you can plug your Arduino board into the computer and test to see if it works. First scan the fingerprint you know you've got enrolled with the sensor. Lights up the green LED. Next try a finger you don't have registered with the sensor. The red LED remains on. You can use this simple code to control any of your Arduino projects, like sound or even a solenoid that locks a safe. It works great with our RGB LCD display, which you can use to show extra information like whose fingerprint it was or deny someone entry to a door. We can't wait to see what you make with the fingerprint sensor, so leave a video response or share your project on our weekly Google Plus show and tell. More information.
Awesome job, Becky.
Yeah.
Okay, there was one question someone had. What if you wanted to replace one that was enrolled? How would you do that?
You can rename anything. It's not permanent, so
Yeah,
you can reuse the flash for whatever. If you need to reuse retake a photo or change which finger is enrolled.
So I'd ask you what number, and you would just say if it was number 4.
There's
you'd
like
just
160
do number
slots.
4 again.
Yeah, and all the code and library is online.
It's on GitHub.
All on GitHub. So
And
that's one of the
Arduino.
things we do. We provide libraries and all sorts of software, open source software for our products. So please buy it from us, because we work hard.
Yeah, there's the step-by-step tutorial shows you how to put all of the things.
Yes.
This video is just kind of like an overview.
Well, if you want to just do the video, I can show you the the step-by-step process.
Yeah,
Because it's like
exactly.
a lot of people don't realize you have to enroll, and that it's not like magical. It doesn't like magically recognize you. You have to
Right.
teach it about your fingers.
Yeah.
Alrighty,
That's pretty
moving
rad.
right along. We've got a new badge in the store. We got permission from the Python Foundation, and we
This
have
is their logo.
Python badges.
That's
Oh,
awesome.
cool.
And a little history with this. Waz suggested it.
I did, because you were like, oh, we need to looking at all the different skill badges, and the badges are really cool. And I was thinking, you know, what else do you need? And I thought about a coworker of mine who mentioned that until I learned Python, he couldn't talk to me anymore. Just because like Python is really.
Wait, but you know like Scheme.
But Python.
Do you tell this guy that he needs to learn a Lisp derivative before he talks to you?
Python is actually super, super useful. You use it in test and data acquisition. You use it in, you know, biological modeling. You can use it in different CAD applications. It's just there are a bunch of like different biomodules I want to use that are
Don't get
based
me
on
wrong, it's
Python.
handy, but I don't think it's a basis for friendship.
I said coworker.
Oh.
But Python is super, super awesome and very useful, particularly if you're doing any sort of computational biology or modeling or things like that. So.
Yeah.
Their logo is boss also.
It is pretty. I had no idea that the Python logo looked that good.
It's a pretty logo.
So it made nice
so-
match.
And then one in the works. Ruby is gonna
You do
be
Ruby
coming out.
logo?
Yeah, we could do Ruby. So that's coming
That
up.
I don't know. I have to learn Ruby. I
Yeah.
haven't had time to learn new
Yeah,
languages
I
lately.
know.
Someone says we need an old school badge, a Perl badge. All right, someone wants to do a little character of Larry Wall and send it to me. Totally do it.
Or a list badge.
It could be-
Lambda,
you
lambda,
could
lambda,
probably
lambda,
do
lambda.
the camel, the O'Reilly camel for Pearl.
Yeah.
That's not the logo, though.
That's not the logo. Yeah,
Is
it's
it the
gonna
logo for Pearl?
work it
Must
out.
be.
Oh wow, someone said lingo. Geez, that's Macromedia.
Yeah.
Macromind days.
I don't think we're allowed to do that.
Yeah, action script.
Macromedia is definitely
There has
not.
to be someone left that you can get.
Yeah. Yeah.
Okay. TCLT TK badge.
We're
Okay.
not.
Tickle.
We are not
No.
doing a Tickle TK
Fortran
badge. I'm
77,
sorry.
yeah.
I fucking hate Tickle.
Hey, Fortran is still used.
Yeah.
Yeah. Fortran.
Cobol.
Fortran's
Cobol badge.
fine, but it's nothing to be proud of.
Cobol badge.
It's not.
These badges are supposed to be fun, though, or not like, oh man, I
Most,
gotta.
most kids don't want to grow up to support legacy code. That's true.
Yeah.
I mean, at least Python is
Art badge or
fairly
vector
used.
graphics. It's, pen. It could be the pen tool.
Basic.
My
Can we,
favorite tool.
can we do Visual Basic?
No, we can't do Visual Basic.
But it's one of the first programming languages I learned.
Microsoft is not going to let us do Visual Basic.
All right, all
badges.
right.
Okay. Next up, we have
They don't
diodes.
like us.
Diodes.
Diode.
Great.
Yay.
So these are a pack of 1 in 4001 diodes. We have 10 in a pack because
Yeah, I was
they're
thinking.
pretty handy. What do you guys want to do the talk or what?
No, no.
I was like they're like debating the diodes. They're basically standard 1 amp, like 40 volt something blocking diodes. They're good for if you're for example you need to take AC convert to DC. They're good for that. If you want to put a flyback protection diode, these are excellent for that too because they can handle pretty big spikes. They're not good for switching regulators, but they're good for like DC blocking as well if you want to avoid polarity problems. They're not super fast, but again they can take a lot of current, so that's why we like these. 1 in 4001 is pretty standard. 0.7 volt drop. Use them all the time.
Yep. Solid.
Handy diodes.
Electrician came by my office to actually get some the other day. He's like,
Handy
what?
diodes.
You don't have H bridges? I'm like, I have a bunch of diodes. He's like, all right.
Make one.
You can make one with
Waz
this
is
one.
mostly made out of diode. Here's can you talk
Sure,
about
Yeah,
this?
you
This
are dressed up as a
Yeah, I was trying to decide what to be for Halloween, and it's not a costume unless it's also an engineering pun, because you can't be an engineer without being punny. And I thought, current only goes one way, so I decided to be a diode. It was pretty classy, a little anachronistic. That style did not come into fashion until the late, that's a 20s fashion, and diodes didn't really come out until the late 30s, early 40s.
Really?
But yeah,
even like
I'll give it to you.
like the first.
the first diodes
Special
were
diode?
like
Like your
after the
hat.
1920s.
Wow.
Yeah, so it's
Pretty
a
smart.
little bit of an anachronism, but no one, everyone's like the line is at the top, and like current only goes one way. So
It looks
that's why
better.
the line
It
has
looks
to be.
better.
I mean, it also looks better at the bottom,
at
but
the bottom. Yeah.
but you know what? Current only goes down.
Yeah.
that's true.
So
To the ground.
to the ground, it's got to go down to ground. So yeah,
I wrapped myself
And
in
you're
red
positively-
cellophane one year, but
You're
that was-
positively biased.
it's true.
I'm negatively.
I'm
biased.
a very forward biased diode.
Okay.
Next up, transistors.
Next up, we have a bunch of standard-ish NPN transistors. These also come in a pack of 10 because they're super handy, and you want to have a bunch kicking around. These are also like 30 or 40 volt transistors. They're the PN2222s, which are, in my opinion, a kind of a better upgrade to the standard 3904s or 3906s. I can't remember which one's the NPN. But I think these can handle a peak current of like an amp. So we use these in the TV Begun because you can spike an amp through them. And of course, the package is small, so they can't handle like an amp forever.
Continuously, but
you can spike an amp through them for a couple milliseconds, no problem. So they're handy, and like they come on tape, and you put them in a breadboard. And if you're ever using you need something just power like up to 200 milliamps, I think they can do continuous or something like that. Depends a little bit about what the voltage is, of course, across them. They work great.
Why do you think that the 2222 is better than the 3904?
I think it handles a higher current spike. I think that's why I spec these, and the VC was lower. I did a couple comparisons. I was like, well, I mean, they're all about the same price, and so what I looked for was, these are the ones we use for the TV Gun, and I spec these. Or maybe I did some tests and I found that they could handle higher current spikes a little better.
Okay.
All right.
A little harder to fry.
Yeah.
Moving right along.
Yep.
We've got this 4 gig card.
Yeah.
You want to talk about this?
Yeah, these are, we updated the micro SD/SD cards that we have in the store. These are used for like all the shields, like the data logging shield, wave shield, GPS logging shield, micro SD, like all our displays that have micro SD cards on the back. It's handy because you get an SD and a micro SD at the same time, because you can just put one in the other and then you can use it as an adapter. And the adapter is just like a piece of plastic. The price of the 2 gigabyte cards and the 4 gigabyte cards is actually about the same on the market now. So we just decided to upgrade the 2 to 4, and it's the same price, which is great. The only problem is once you get after 2 gigs, you're no longer in SD card territory, you're in SDHC, high capacity territory. And this is kind of unfortunate because I actually don't like the SDHCs because some older devices don't support them. It's a newer standard and it's not completely backwards compatible. All of the stuff in our store is backwards compatible. All the code is in the Arduino library for SD, which I maintain, is SDHC compatible. But if you're using this with a really old project or really old computer, you might need to get an SDHC adapter. It's a little unfortunate, but fact is, these SD cards are going to go away. They're going to be eventually discontinued, and if not, the price is actually going to go up because
there's not the demand anymore.
No demand anymore because every new camera and every new device is going to be using the 4 gig cards. So we decided, like, well, we could try to like keep on with these old cards. We could just go forward and say, look, we're going to, everything into the shop supports it. Let's go forward with the 4 gig cards because you get twice the capacity.
Yeah.
Okay, some good questions. Someone wanted to know, that's going back a little bit, is there a higher current version of the 3906?
You would go straight to that TIP 120 or something.
Okay. Have we seen Bunny's super cool article about the counterfeit SD card? Yes.
Yeah, these are not at all counterfeit. These are like brand name, genuine, like known
good vendors.
Known good vendors. We don't buy cards on the gray market. We buy them only on the white market. Yeah. So that's why we don't have them for like ultra cheap. But when you get them, because we did once buy a bunch of SD cards from the gray market, and it was like a bad scene, not suggested. So
yeah,
anything we have in the store is like brand name, high quality, guaranteed to function, and guaranteed to have the capacity that they say they have.
Yeah, I love Bunny's article though, but yeah, I mean, we've gotten burned on gray market parts just trying to find some random weird part from China, and then we're totally non-functioning.
SD cards are like the first thing that they scrape off, and they say, instead of 4 gig, it's really a 1 gig card or whatever, or it's failed tests, and so it has bad blocks, and you don't find out till later.
Okay, next up, do you know the temperature rating for these SD cards?
No, I don't, but they all pretty much, I think, work on industrial temperature range.
Yeah. Next up, are there any code changes Arduino-wise to support SDHC?
In the SD library, it supports both. If you're using the SD library, you have to make no changes.
Do you work on that SD library?
I maintain the SD library.
Oh.
That's how I know.
That was called a setup. Next up.
I set up!
Okay, good. We're moving right along.
Okay, great.
Yeah. We got glands.
Glands!
These are exciting,
Everybody's been sitting around waiting to say glands.
Waiting to say glands. Okay, on the overhead I can show you. These are actually kind of weird.
It is like saying
lozenges. I'll show these.
Do we have the overhead?
Oh yeah,
overhead, so I can show what these are because they're a little unusual. So
and that cutaway doesn't really show what's inside them either.
Yeah, so glands are made out of 3 parts, and I'll show the 3 parts. So you've got this basically ginormous hex nut, and you've got this. It's actually it's also kind of a rounded hex nut, but it's actually tapered.
Yes.
You can't quite tell yet, but you'll be able to see in a moment how it's tapered. So basically, if you have a cable and you have a waterproof box and you want to maintain the waterproofness of the box, so here, for example, we have our waterproof cable, and let's say this is a power cable. So, for example, let's say we want to have this on the box, and then we'll have this waterproof connector go from here to, like, say, a solar panel or something. So what you're going to do is take the gland, and over here you see inside there's a little black gasket, and there's some of these soft fingers, and it actually acts kind of like an iris. So what you do is first you put on the rounded part, the tapered part, and then you put in this, the actual gland itself. And then when you screw this on, what happens is it tightens the gasket onto it. And so as you tighten it all the way, the fingers close in around and press the gasket to be air and watertight against the cable. So as long as your cable is fairly round, it's now got a waterproof seal. And then on the other side, you can simply connect this to your box, and so the wall of your box will go here, and you can just, these are backwards, you can just attach it, and then you can use gaskets if you want here, if necessary or not, and then over here you've got the loose cable. So this lets you have a waterproof seal for an enclosure and still have cables come out of it, which is a common problem. And these come in two sizes. There's the 7 size and the 9 size, and the diameter of the cables that these support is slightly different. This one can support slightly larger cables. Check the product pages for exactly what diameters of cables they support.
Yeah, and it's really important, right, to make sure you've got the right cable diameter for the right gland, because it's a compression fitting.
Right.
So if you've got too much slack, it won't fit.
It actually won't fit at all. Like, if it doesn't fit through, it won't fit.
But if it's too small, then no matter how much you tighten it down, it's not going to make a good seal.
Yeah, you want to make sure that when you yank on it, like, you're going to yank. I mean, I'm just doing finger tight. You would actually use
wrenches and tighten it down.
So, so these allow you to keep a enclosure waterproof. So this is a really good addition to the waterproof cables we have, because a lot of people said, well, I've got these waterproof cables, that's fantastic, but if I have an enclosure, how do I keep the enclosure waterproof? Like, because I want to have my whole project be weatherproof or waterproof. So that's how you do it.
And then, do you want to talk about this great tutorial from Free Glass, who's also in the chat, by the way?
Yeah, Akiba wrote an awesome tutorial because he's been doing safe cast projects, and so he's been working a lot about waterproof boxes. And when we went to Tokyo, he talked to us a little bit about how he did it and showed us, like, where he bought all these components. And so that's where I got the idea of, like, hey, we should have these cable glands to go with our waterproof cables.
Yeah, so you can check out his tutorial. Maybe he can post up a link in the chat, because I don't have the link handy. I don't know where it is. Alright, next up. Lots of wires.
Okay, next up, I'm going to show off these really handy wires. So, again, on the overhead. These are premium male cables, so they're ribbon cable. So you can see this is a 40 pin wide ribbon. And we have these little machined plastic parts with points on them, and so they fit perfectly into 0.1 inch spacing, so it's very handy for a breadboard, so you can fit as many as you want, and they're like slightly less than 0.1 inch, so you can stack them either way. And the nice thing about these cables is because they come on a ribbon, you can tear off sections at a time. And so if you want to do like a project where you have like a bus line of 8 wires, you could tear off 8 wires and have them all in a row, and so you don't get as tangled wiring. You have a nice wire harness. And they're also very nicely color coded. They come in 10 colors: black, white, gray, violet, blue, green, yellow, orange, red, and brown. So you get 4 of 10 colors, so that's plenty of colors to keep track. And we have a couple different sizes, so maybe on the big screen.
Big screen.
Thank you, Vanna Waz.
Activate a big screen.
Okay, thank you. This is the 12-inch model. This is the 6-inch model. And then we have the petite 3-inch model.
But the nice thing about...
which is wallet size.
For the engineer on the go.
For the engineer on the go, who doesn't want to have to deal with bundling wires, because it's really nice. You can just...
Yeah, you
really
can tear these. And then you can... of course, they work with... they're super strong. They're a little bit more expensive than the rubber-ended ones, but they're a little bit nicer quality, too. And, of course, they come in the ribbon. So we have these in female-female. And we'll be getting female-male, of course, and different lengths of all those. We'll have 3, 6, 12, and all different sizes. We got these first from the factory. and we want to put them in the store. So these are, I think, a really great way to do wiring.
Okay, quick question. Do you know the gauge of the wire?
I think it's 28.
28.
Okay.
It's 28 or so.
28 or 26.
Next up, are there male-female ones?
We don't have male-female ones yet, but what you can do is you can get the female-female ones and then our extra long headers and you stick them in the ends. But we'll have those in a few weeks. We're just waiting for those to get done.
So
Alright.
they're in process.
Okay, moving right along. This is a kind of an interesting product that's outside of stuff we normally stock.
But you really liked it.
Well, yeah, I guess I can introduce this one, or maybe Becky.
Yeah,
and
you're
she'll
the
talk about
ones
this
who
again.
actually, you got to play
okay,
this.
I'll just poke in for a second. That's me.
Oh.
I'll get close. Okay.
Hello.
Hello. This is a product that I thought was interesting. So we have the power switch tail.
Mm-hmm.
Basically, it's a relay that controls a power strip and extension cord. And you can have an Arduino control. You can have all sorts of things. Very cool.
They have to wire it in.
But you have to wire it in. And for some people who just want to quickly be able to turn on and off something, they do LED installations, and the stuff is like tucked away or it's just hard to reach. This was a really interesting product from a company that I just happened to see online. And what it does is it controls a Bluetooth extension cord via a sound profile. So it's the
A2DP.
A2DP.
It's the audio profile.
It's the audio profile.
So it
which
looks
is
like
clever,
a speaker.
Yeah, it's a very clever hack. So it plays a specific sound, but it also has an iPhone, an Android app, and you can also use any type of computer, and you can probably use anything.
The only thing is you can't use an Arduino or microcontroller because there are
right.
no Bluetooth modules that will mate with the.
Not yet.
I don't know that actually that is even possible. I don't know of a Bluetooth microphone. I mean, there might be one that can do it.
There's the
I
audio
don't
profiles.
know. But there isn't anything on the market now. But this is good for people with an Android app or something where they want to add power control, and you can do it locally without having to use internet stuff.
Yeah, and so I'll answer a quick question on this. It says if it works with an iPhone, does it mean it made for iPod chip inside? No, that's how they get around this. So all that stuff,
audio.
It's just all it is that you pair it to the extension cord, and then you just run the iPhone app, and it just plays the sound over the Bluetooth audio, and that's how it turns it off.
Okay, so the iPhone pairs to the switch
Yep.
like it's a speaker.
Yeah.
Yes.
And then it says, "Hello, my Bluetooth friend.
Yeah.
Play the following sound." And that sound
that's how
is
you
the
turn
control
it on
signal.
and off.
Okay.
In
That's why
fact,
it can even work on the web interface.
Yeah.
In fact, luckily for us, who made a video recently?
I did.
Okay. That was also a setup. So let's watch this video real quick, and you can check out what it does.
Today we're looking at the Smart Cord from Z Smart Company. It's essentially a Bluetooth-controlled extension cord. You can use it to remotely control anything you'd plug into the wall socket. I keep a power strip on my desk to turn on and off devices I don't want to leave on overnight. This will save me from having to keep that strip on my desk, and I can control it with any Bluetooth device like a phone or computer. It behaves like a Bluetooth headset, which means it'll even play nice with things that aren't friendly to third-party devices, like your iPhone. There's even a web interface that'll play the control tone through any browser. It sounds like this. Did you hear it? I'll play it one more time. It's really straightforward to set up, and the app runs on all kinds of platforms. I find it really useful for turning on all my photo lights without getting up from my desk. And, turning them back off again. Oh no, did I leave my soldering iron on? I'm already in the kitchen making a sandwich. Phew. For more information about the Smart Cord by Z Smart Company, visit Adafruit.com.
Okay.
Nice work.
Yeah.
Yes.
So anyways, this is an interesting little peripheral because we're seeing lots of people do lots of cool stuff with LED stuff that always seem to be a way, and I thought this was a cool, fast, easy way because everyone has a phone that can do this. And that's why they went with this kind of, I thought this was a clever way to make complete device compatibility without even having to go through the hoops of getting like made for iPod certification, all that stuff.
Yeah,
It's
It's
actually
really good for art installations. Like I used to install stuff as my student employment job, and like students would never be able to figure out how to make their projects like automatically turn off and on easily for like gallery staff.
Using X10 is like really buggy and it doesn't always work through stuff. This is super easy.
Yeah. And one thing it doesn't do is like feedback and tell you whether the thing is on or off.
Someone just asked that.
It's just treating it like a speaker, so it's only the communication is only one way.
Yeah.
So I can't know for sure that I actually turned off the soldering iron. Like,
or
it's
if
not
you're
good. Like if you're like the ranges, they're Bluetooth, so you could do it for like an apartment. You can like, oh, did I turn my thing off? And then like from outside the apartment do it, but you can't know that it actually happened unless it's your lights and you can see.
Yeah. So then ideally it would be some Bluetooth device that has a two-way profile that it can.
Yeah, but like that's the whole thing about their thing is the reason they do it over audio that way is because it's so versatile and you can do it on any device, your like iPod or your.
And it's $39.95. You know, a lot of folks are like, oh, I would like to have it all do this stuff, but I'll make it Wi-Fi, and then all of a sudden it's like, this is a $500 power cord.
Yeah. Feature creep.
But you can write all kinds of scripts to like activate this thing on your computer, like from the internet while you're not home, or like there's all kinds of stuff you could do with it that's pretty. And
you just
fun.
make sure that your, the state is synced up with the script. So
right, exactly. Just write clean code, and like if you're within range, it's never gonna miss it. Like I never had it not trigger it when I was within range.
Yeah.
Someone wants to know, is we have one open yet? Yeah, we took it apart just to make sure they did a good job and they have a nice relay. And we looked at the Bluetooth chip because we're looking at, as we talked about in the past, we're going to fix Bluetooth and have a cool series of Bluetooth things. So we liked what they did, and that's why we bought it. We checked it out before we purchased them. Okay. Next up. Level shifter.
Level shifting.
Okay.
You want to talk about these?
Yeah. So this is a little level shifter. We actually have a couple level shifters in the shop, but the problem is none of them were I2C happy, and so I wanted to have something in the store that was good for I2C. This guy's really slow.
Maybe because you're here, could you talk about why and what a level shifter is and why someone would use one?
So a level shifter is something that we were talking about TTL, but a level shifter is basically, chip A and chip B have different definitions of what a 1 and a 0 are, and in most chips they have like a cutoff voltage that above that V out high is a 1, and they have a cutoff voltage about like below that is 0, and different logic series need different logic levels in order to interpret data. So if you've got a 3.3 volt device, it thinks anything above like 2 volts is a 1, and anything below 1 volt is a 0. And then a 5 volt device will have a different cutoff, and its cutoff might be above 3 volts. So you can't really chain them together. The problem is sometimes you'll miss valid values, sometimes you'll pull a pin too high and actually cook apart. And I2C is particularly finicky for this, just because if you look at like the I2C spec, it has pull-ups, and so the interaction between devices with a level shifter in the way can actually be really hairy. So a lot of standard level shifters, you can't even chain them. Or at least a couple of years ago, you couldn't. So it can be a real pain.
There's special I2C level shifters like this, but most of them are not.
Most of them are not that good. Yeah, they're not truly bidirectional. So
right. So as I quickly showed, that there's one side that's high voltage. I just say 5 volts, but it's actually up to 10 volts. And then there's a low side, which is, I say 3 volts here because it's most common, but it goes down to 2 volts. And between there's 4 pins, and each one of them is independently bidirectional. And the way this works is actually really neat. This is in the spec sheet, the app note from NXP that is linked off of the product page, but I'll show it off really quickly. So, let's see.
Yeah, good.
Make sure this is good.
That's good.
So this is the low voltage side, and this is the high voltage side. This is
the back diode.
Yeah, and this is tied to here. Am I correct? I thought I had my notes with me.
I don't see them. That's not your notes.
All right, hopefully this is correct. So the important thing is that there's this diode. I always get the diode backwards, but I'm pretty sure it's this way. And then this is the gate, and this is the source, and this is the drain of a standard N-channel FET. And the way it works is kind of interesting because there's 2 pull-ups, these resistors here, and normally the gate is tied to, let's say, 3 volts. So the gate is tied to 3 volts, and the source is pulled up through this resistor here, also to 3 volts. So the volt to gate to source is 0, which means this is off. So since low voltage is lower than the high voltage, these are disconnected pretty much. The diode isn't conducting. or maybe the diodes are the other way.
I think
No, sorry, the diodes is right. It's connecting, and both are pulled up high. So that's the default state. They're both pulled up through this, 10K resistors. And then if the low voltage side is pulled down, then this is 0 volts and this is 3 volts because it's tied here. So VGS is turned on. This MOSFET's turned on. This FET conducts, and then this pin goes to 0 volts because LV is at the low voltage side is at 0 volts. And if the high voltage side is at 0 volts, then this body diode inside conducts, and so the low voltage side is at about
0.6.
Not like 0.6 or 0.5. It's a very small diode, and the current conduct is very small, but it's good enough for signaling. And so that's how it works. Basically, the default is it's pulled up, and then each side can pull the other side down.
Yeah, so it's active low bidirectional.
Yeah, so it's active low bidirectional. And this is really good for I2T because I2T is an active low
protocol.
bidirectional. Yeah. So, but this actually works with other protocols, TTL or CMOS or serial type protocols. Yeah, because they're active, but it doesn't matter because they just ignore the pull-ups.
Right, and no matter if you've got this, as long as all of the relative voltages in the circuit don't exceed any of the breakdown limits for that MOSFET,
10 volts,
then you're fine.
You're right. As long as the high voltage is higher than the low voltage side, and this can go up to 10 volts, and this can go down to 2 volts because the VGS has to be about 2 volts for it to turn on. And this works really great. And there's 4 of these on the circuit because you can use this for 2 I2C lines or I2C in serial or a SPI or something. The only thing is that it, just watch out for the resistors. You want to make sure that they're about 10K, just so you because there's a capacitance on the gate, and you just don't want it to slow down. But like I2C is so slow, it doesn't really matter.
Yeah, 400.
That's why this isn't used for higher speeds sometimes. Although I guess the pull-ups don't really matter. So it's a very funny hack.
So the thing to note about this is that you can't really chain these too many times, depending on what you have.
Yeah.
Because if you've got
so it's not a lot of space on this.
Oh, one quick question: max switching frequency. Someone wanted to know.
The max switching frequency depends on the first off, if it's a pull-up based system, it depends on the pull-ups and the capacitance of
the line.
The gate. This capacitance here, which you see as part of the FET, the gate to body, which is gate to source or gate to drain capacitance. I don't even remember the name of the capacitance. Is there a name for it?
It's the body capacitance.
Body capacitance. I thought it had a funny name like Miller capacitance.
Bulk. No.
Well, okay, so it's a bulk capacitance. That capacitor coupled with this resistor does create a low pass filter. So I don't think you could probably take this beyond maybe 50 megahertz or something.
Right, and the other thing is how fast you can drive it will depend on how long your line is, because if you think about, you've got this capacitor here, but you've also got a line, a transmission line.
Yeah.
So if you've got like a long coaxial cable hanging out, like if this thing's 20 meters long of coaxial cable, that's also
more
a big,
capacitive,
giant cap.
Basically, whenever you have pull-ups as part of your protocol,
you need to worry about line capacitance.
All the line capacitance and the capacitance of the input pins and the MOSFETs make a big difference. And so, but again, like people who are doing this stuff, it's like they're not usually
super high frequency.
They're not usually high frequency, and honestly, even like non-pull-up based stuff like SPI has problems at high frequencies.
Right. So here's the chaining thing I wanted to mention, which this is pretty similar to what NXP had before. So you mentioned that if this is grounded, right?
Yeah.
Then this is going to be 0.6 volts.
Right.
And so if I'm going to draw the thing as a block, if logic level 0 here is 0 volts, and logic level 0 here is 0.6 volts, and you have another one of them, then logic level 0 here is going to be 1.2 volts. And on and on and on.
I don't know why you would ever chain these though.
You actually chain them to try to get over things like this big line capacitance. So everyone goes, oh, I need
you could just make the resistor much lower, no?
You could make it much lower, and you could also a lot of people just try to get around. They try to use bidirectional level shifters, not as level shifters, but as buffers, and they don't work that way. So
they don't work that way. If you're doing that, and it's a bidirectional, first off, like no bidirectional transmission should be going over like 20 meter capacitance coax lines. But if you're using, if you're doing any kind of long path time type that, use terminators. Like terminators are great. and they use diodes, and we have diodes in the store now. So
Yeah.
you have no
Yay.
excuse not to use termination diodes. Okay.
Okay.
Next up, the end.
Next up, world premiere. This is a big deal.
Okay,
so
Waz, are
excited.
you ready? Are you
I'm
ready?
ready.
Are you ready? Are you ready? Are you ready?
I'm
Okay.
You guys ready? I'm just waiting.
Oh, we are
I'm ready.
ready.
Okay.
We're ready now.
Wait,
Yes.
you guys say you're ready. Okay.
Come on.
Anyways, introducing the Bento box.
This is Waz's
Yay!
project. We finally got this done. Thanks to Becky.
It was previously out on Don't Ask. It's not out yet, but now it's out.
Yeah.
And this is why your code for this evening is Bento, B-E-N-T-O.
And this is on sale.
What
too.
is a bento, Waz?
A bento box is a Japanese lunch box where you open this box and it is full of delicious, tasty treats.
I'm moving out of the way.
So so basically you open up a really awesome waterproof Otterboxen, the Otterboxen, and inside are all the tasty treats you need to do fun with electronics. So there's I sketched out a couple different versions. I think you've got the main version.
This
in
is the
store.
version we decided on, the one with storage in it.
Yeah, so we've got an Arduino mounted in the center with room to put in all of your fun connectors. There's a proto board, and then there's an Altoids tin for storing all your
Wanna do
parts.
the overhead?
I'll do the overhead.
Yeah, I actually I
Um,
tucked my wires underneath there, so this is kind of confusing. Like,
Yeah.
what is all this extra stuff?
And then those are some extra wires. And it's got
I'll
enough
put those
vertical
wires.
clearance that you can put, jumpers in and put components on the breadboard.
Phil, is there a way we can move the bug or the?
The
Do
Ask
what?
an Engineer.
Want to move that out of the way?
Yeah.
I
Yeah,
go with
maybe
that.
just.
Everybody knows what they're watching now, right?
Yeah,
Yeah,
they
I think they know.
Okay.
Thanks.
Yay! And so, you've got room to actually put like fairly tall components in, hanging out on these headers,
Yeah.
and you can still close the
And you
lid.
can see the nice wiring I can do because I'm using the
Yeah,
the-
using
the
the new
bundle
jumpers.
wires.
Yeah.
and then I'm using the little strip here too.
Yeah.
So yes, there's a plastic case here, the plastic part. which
Yeah,
is
it's
sort of
just a
cut
press
out.
fit plastic.
Just
um,
clear, so it's hard to see it.
Yeah, and this was pretty the way that and I can show
Well,
you.
let's show this, and then you can talk
Okay.
about it. Yeah, because otherwise you have to go back and forth. Okay,
Yeah.
so then the first up is the Arduino in the center.
Yep.
Yeah, and then you
It's
back
just
it
got-
up so you could.
Yeah,
you
back
could-
it up so you could get like all the different cords in.
Let's go USB cord.
Yeah, we've got one here.
Okay.
Yep. And
So
then
it plugs in nicely.
we've got something
Storage.
fine. We've got storage. Plenty of storage. You've got a lot of different stuff in here.
ESD safe storage.
Yes, it's true. You can ground yourself on your tin before you can touch the tin before you touch the things inside. Then you won't shock them. And then half-size proto board.
Right, and then so you can take this on the go.
Yeah, so
work
basically
on
it's
stuff.
meant to be a project pack. So you put all the things you need in it, and maybe it's a working circuit with data logging or whatever, and you close it up and take it where you go.
And it's
just like with the Bento
waterproof
box.
and crush proof and
Yeah.
everything proof.
Yeah.
Okay, so the hardest part of this project you said was getting the tin to it really press fits in perfectly.
Yeah, I really love dimensioning parts, and all of this stuff. Because if you look at this, all of the things are pretty easy to measure with calipers, except for the tin. So with the half-size breadboard, it's rectangular. With an Arduino, I can pull all the dimensions out of the CAD file. But getting the exact outer dimensions of the Altoids tin required a little bit of work. So I came up with a quick trick for people to do. Hopefully this will show up. So a lot of people had figured out what the inner radius of the Altoids tin was because people want to put boards in there, and the inner radius sort of, you have to account for this extra lift, like you don't really know the wall thickness.
Yeah.
And what I wanted was, am I good on center? Yeah. What I really wanted was the outer radius. And I'm like, well, I don't even know if this is like a full radius. So what I did is I just put it down on paper and I traced it like that. And then if you take this and line up part of the curvature and continue to trace around like that and just keep on rotating by a small amount, you have to be good with lining your pen up at the same time, at the same location. But you can begin to construct basically a circle without any math, without having to worry about tangency or am I getting directions right. You start slowly building up an outline of the outer radius.
So you're just doing it like 1/20th of a circle at a time.
Yeah, I'm just like slowly going through and doing it a little more at a time. And if you're really careful like this, you can get very good line thickness so that it's pretty precise. And so I did that, and then just got calipers and went across and got the diameter, checked it in a couple different locations, and was like, oh hey,
and
look,
it worked. It actually,
it's 26, and I'm like, oh, how do they want to manufacture this? They probably are going to have on the millimeter or on an increment of an inch. No one has like 0.0032 millimeter measures.
Right.
So when the caliper came out, for this one, it's 26.52. I'm like, okay, it's 26.5 millimeters. That's the outer radius.
Yeah.
And it ended up being a really good fit.
Yeah. So the nice thing about the fit is because the tin is stuck with the foam tape. It actually holds.
It
holds
it
in because the thing is, you don't want to. There's no way to really glue the plastic in because this is like.
It's acrylic. You want it to float a little bit,
yeah.
But you want it to, and if it's too tight, you can't fit anything in, and you'll crack the acrylic.
Yeah.
If it's too loose, things shift around, and the tape won't really do a good job of holding it in. But if it's just right, then it's just right.
Yeah. When I was in school, I had to bring my physical computing project in like a take out food tin, and I put it in my bag, and then like it would fall around, the wires would fall out, and then it wouldn't work when I went to present it. And this is like the perfect thing because you can just like shove it in your bag, and none of your wire connections are gonna get knocked around.
That's totally why Woz designed it.
Really protective. I don't carry circuits back and forth as often as I used to, but man, college Becky could have really used one of these.
Yeah. Our nerd kits at MIT were these things that looked like briefcases and had.
They were so goddamn heavy.
They weighed like 40 pounds.
They really were. They were. They were made of solid wood. And they were beautiful, but they were like butcher blocks.
Oh, you're thinking of the power electronic ones. I'm thinking of the older ones that were covered in leather.
Oh no, no,
leather.
They changed. No, they all
the
the
new
labs
the new
changed.
ones are wood now. Like
Yeah,
nice
the wood
boxes,
ones.
but the old ones were leather. And
They weren't as heavy.
No, they were heavier.
Really?
Yeah,
See,
because
I
they
didn't
had
take-
like these ridiculous power supplies.
I didn't take it.
And they had like row after row after row of breadboards, and like so many generations of students were shoving the jumpers in way too hard. So like you had to know that nerd kit number 214 had a bad sector of the breadboard, and whatever you do, don't put your analog circuit there, because if you tap it wrong, like 12 volts comes on and off, and you cook stuff. I might have had that problem, but that was not my nerd kit number, and it's since been retired because they reuse them every year. But yeah,
No,
just like
they
lugging
were
that
in-
thing home was painful, and even though everything was bolted down, it had so much mass that it was like shaking.
I don't even think I think I had one for Analog Lab. I didn't even take it home.
I had one for Digital Death, 6111. So like, and 6111 is all TTL logic, so you've got giant bus wires going everywhere, and one falls out, and the whole thing stops working.
And that's why it's now all FPGA.
PGA.
Okay, that was it for new products.
Any questions about
Yeah.
the
Yeah, I'm gonna open it up to general questions, but that was it for new products. Thank you, Oz, for doing the Bento box. Another awesome addition. One of the things that I've seen is Lady Ada's a neat freak. Everything's always tidy around here perfectly. But sometimes we get a little busy and things get messy. I've noticed that this has helped out though with your projects because you're able to keep stuff in a tin.
Because I have to go when I go home. I put
Yeah.
all my stuff in here and I close it and I can just toss it in my bag.
Yeah.
And the thing I like is it's just like I can. It's like unlike most project boxes, I don't have to worry about stuff hitting other stuff or wires coming loose. The way it was when I put it together is the way it is when I get home.
Okay. We're gonna do general questions real quick. People are starting to ask, so I'm just gonna do that. General questions.
All right.
First one.
Yay!
I'll do the yes or no one.
How much do you hit?
I'll do the yes or no one real quick. Is there any way you could pull a bitmap off your fingerprint sensor?
You can, I think.
The Windows software.
The
I think you
Windows
can.
software does it, but I don't know how to do it with Arduino.
Next up, for Woz, do you know any good ways to implement a transmit side of a RS-232 on a hardware, no microcontroller system? I seem to remember it to be part of your example project for your open source hardware summit talk.
I didn't do RS-232. That was half duplex UART running at 9 volts.
Which is about the same.
Which is about the same. So
You can do it with the shift.
yeah,
register,
you can do RS-232 level conversion with transistors. I did the half duplex UART literally just using TTL logic and gates.
You can do it with gates and like dip switches. It's
Yeah,
just
you can do it
kinda-
with gates and dip switches, and then it's a matter of clocking it. So if you wanted to do it without a microcontroller, and you were willing to sort of set up the data you sent and then clock it out, you can do all of that with flip-flops and switches if you really wanted to.
Or you can use a microcontroller.
A microcontroller is pretty nice.
Pretty good at that, yeah.
They're really nice.
That's like the first thing.
I actually really like using Arduino for everything now because it's so convenient. I like micros.
Okay, next up. What are you drinking? What type of beer is that?
This is a Belgian-style pale ale, Pale Moon from the Blue Moon Brewing Company.
Okay. When is a homebrew badge being created? We actually have one.
Oh.
We have the beer
It
badge.
looks like a beer
Yeah,
mug.
sweet. It looks like a frosty
Yeah.
delicious
It
mug
could
of
be
beer.
root beer.
Could be your beer.
Or beer beer.
Do we know the diameter or size of the weatherproof JPEG camera that he wants to purchase a gland for it?
Oh, I don't. But if you send email, I'll
Send
take
an
a
email,
measurement
post
of
in
the
the forums.
cable.
We can help you out and do that.
You-
Next up, can you quickly describe what a terminator is?
A terminator is basically 2 diodes that when you have, basically what happens if you have a high frequency square wave and you have capacitance, math, you get oscillations on the, when the line goes up or down, you get oscillations up and oscillations on the bottom, and so what happens is that these spikes can cause glitches.
Yeah, ringing.
I mean, it's like what? It's like the capacitance.
It's
goes
underdamped.
forward. It's underdamped. So basically, there's one thing you can do. One, you can put a resistor in series.
And bleed off that extra energy and
You
sort
can
of
bleed that
critically
out.
damp it. Yeah.
But the problem is you have to be very careful about it, and it depends on the length, and it's kind of a pain in the ass.
Right,
and
because then the resistor combined with the capacitor makes the whole system frequency
and then
dependent and can
it can
change your
slow down.
bandwidth. And
So it's kind of a bad scene.
slow down your edges.
So instead, what you can do is to avoid those spikes, you I guess snubber them. I guess would be the right term.
Yeah,
you put
shunt them.
diodes.
You shunt them with diodes.
Yeah, you put diodes so that any voltage on the line that goes above the VCC or below the ground gets
Conducts.
shorted.
Yeah.
Gets conducted back to the rails, and so that basically it's short.
Well, it's
shorting
transient.
out the-
It's transient suppression.
yeah. It's
Yeah.
kind of, so you still get a little bit, but it's under.
It's under a certain threshold that
threshold.
like will probably not cause things to glitch.
And you can use 1 in 4001s, which are actually you use 4148s, which are very fast. I've used Shotkeys or 1 in 4001s.
yeah, and if you have like really specific needs, you can use like TDS diodes.
Yeah, there's no special diodes. I've
Yeah.
just used whatever.
Which is
but
transient voltage suppression. But yeah.
Yeah, then this is why people are like, the longer the line gets, it suddenly stops working, and that's basically what's happening.
Okay, we're going to have to go fast. Speed round, ready?
Yep.
What are the advantages and disadvantages of optical versus capacitive fingerprint sensors?
Optical, it's just, I think it's, first off, it's easier for the user, because you don't have to like drag your finger. It's just, you press and you're done. Second, you can get an image if you want, and so it's good for logging. There's a way, I mean, the Arduino library doesn't do it. It's possible, but I didn't write that code. You can grab the fingerprint, and so for example, if you want to log what fingerprints have been used, that could be handy. But I think it's just faster and easier.
Okay, I need a reliable way to read 2 rotary encoders in a busy Arduino sketch. Any suggestions?
Interrupts.
Interrupts.
2 interrupts.
Okay.
And rotary coders are not that fast. People always freak out, but they're actually like very slow, like 10 milliseconds.
It's a lot of time.
It's a lot of time.
Okay, next up. Can Arduino do 9-volt logic?
No.
No.
Okay.
Maybe use a level shifter.
Is your fingerprint sensor vulnerable to the gummy bear hacks, a la Mythbusters? We
I
haven't
get
had
some
gummy bears yet.
I wouldn't use this for like securing your gold stash.
I don't think anyone should use an Arduino for medical equipment or for protecting valuables quite yet.
Or guns or
guns and things like
Yeah.
that. Not yet. Did you and Lady Ada do the MIT student engineering competition?
Oh, which one?
Yeah,
We
there's
did-
like 8.
We did 6270.
Is that the answer?
That,
Okay, we're gonna keep moving.
Who
Okay.
knows?
that's the one we did.
What's a good instrumentation amp that can be used on an EKG or an EKG?
For an EKG, I actually like using the 8622 from Analog Devices. It's an older
Classic.
inamp. It is a classic inamp. They have a bunch in that series. 8622. Or sorry, I used the
Wait.
8621.
Is it 62? Isn't that a multiplier? No.
No, 621 is a dual input inamp.
Mhm.
There's also the 623, the 626, the 627. There's a whole bunch in that series. There are
I
a
see
bunch that are
people
newer
using-
than the 621.
I'm not going to say that TI is better, but I do see people using the OPA like 230.
And the OPA, like the OPA series, but I generally use the Analog Devices, not because I worked there, but that's because what I worked with for doing EKG stuff.
They do make good op amps.
Yeah, and so if you have different power requirements or different noise rejection requirements, just go through the 6.2 series and look at the different trade-offs in the data sheets. They have like different
Nearly all
noise
of them.
floors, different rails, different gain ranges. Like the 8621 is nice because it's pin set gains of like 10 and 100. And other ones are 2, 5, 10, and some are continuously variable based on how you set the gain resistor. So really,
And
there's a
usually in
lot
the-
of flavors in that
In
series.
the app notes, they tell you even how to set
In the
up
app notes, they
EKGs.
tell you exactly what to do.
And they often have an EKG schematic. I know, because it's
and
stolen it.
I haven't been able to find it recently because MIT's been changing sort of some of their courseware stuff. But you can try to find the course notes from 6121J by Steve Burns, And there are a lot of examples of doing a standard EKG circuit in that if you don't already have one you like, and that uses the 621.
Okay.
Go 61.
Can the Tweedlewatt Python code work for DC voltages as well as AC voltages?
Sure.
In kilowatt? Okay. Next up, Waz, do you have any examples of an open process project? I think someone must have seen her.
Open processing?
Yeah.
No,
No,
open process?
And
Open
then
process
management.
project.
Process management. I'm actually working on documenting it. So one of the things, I know I've been going around and talking about engineering design process, and I want to document it. I got slammed at work for a couple of months. So my personal project is to sit down, and what I'm going to use as an example is going to be the Ninja Badge 2.0. And I have to go through the channels to open source the thing I talked about in the summit. I just have to go through some Harvard bureaucracy to actually get that open sourced. But I'm working on that so that I can release everything for that so people can start using that for robotics. But I have to get permission because they paid me.
Someone in the chat was asking folks in chat, but this is an interesting question for you guys too. So did you see the 6002 MIT X course that they put online?
Yeah.
What do you think of it?
It's definitely interesting.
Do you think it's possible to take this online?
I have negative bias. You have positive bias.
Well, the thing about 6002 is
It totally sucks. Let's be honest about it. 6002 is like the crappiest, hardest, most annoying, most frustrating EE class that
I nearly
you have to take.
changed majors after taking
It
6002.
is painful and unpleasant.
I gave myself one more semester of doing electrical engineering,
Like pulling teeth.
and it's the thing about 6002 is it's all differential equations all the time, and 6003 is let's do things in impedance space.
But then they spend all this time with like digital transforms.
But a lot of it is that, and I talked to one of the faculty members who was involved in the original structure. I mean, I think it's really great that they're doing online teaching, and they're trying to get this to be more interactive.
Here's the
just like
problem.
Coursework, but
everybody wants 6002 online, but I don't think anyone wants to take 6002
But
online.
the problem with 6002 is that there's all this really great electrical engineering curriculum, and someone like 6003 got all the really cool, easy, fun, more intuitive stuff, and 6002 is time domain, painful differential equations math, which is, time domain and frequency domain are the two halves of everything you do in electrical
don't
engineering.
get involved in the time.
But it's just like
don't teach 6002.
it's so hard to do a lab remotely. I haven't seen. I kind of meant to sign up for it, but I also didn't want to sign up for it. I don't have.
Why would you sign up for it? You already took it.
I want to see how they're teaching it. I really want to see how they're teaching it because I want to see if that model works. I think it can be interesting. I really just don't know how Sussman and Peter Mitros and all those guys are going to do it.
I have extreme faith in Sussman, but I believe it's going to be like every MIT class where the first 2 weeks are totally fun and awesome, and you're like, I'm so excited, and then week 3 on, you want to die.
To Sussman's credit, he's been trying to find a way to teach electrical engineering to people where they love it the entire way through, and I think that's one of his missions in life. Like, he really cares about trying to get this material through and approachable to everyone.
It's really cool to like read Thevenin and Norton equivalents, but then by week 3 you're like, I'm really sick and tired of doing these over and over.
But what would you do if you could step out of doing 002 lab work, where you're like, why am I doing this? This is so reiterative, and say practical application time.
Doesn't matter because the practical application is irrelevant. You still have to go through and slog through the math.
That's true.
And you know what the fact is? You have to do the math. If you and I did not do the math,
then we wouldn't have any intuition.
You have no intuition, and so you can't understand the low-level analog, which is fine. Most people do not need to know or want to know the low-level analog. They're better off not knowing it.
That's true, because if they get confused and get it backwards, everything blows up. But I don't know. It's we'll see how people do. It's really like of all of the courses to teach first on MITx, 002 is a real kicker. Like I don't. It's intense. It's a little hard.
It's funny that because this is the thing that I see from my point of view. Everyone wants to be an EE overnight, and it's like, oh, now I can take this class on MIT, and all I hear is your horror stories. It sounds like this is one of the hardest ones to start off with.
Read Horowitz and Hill, and the first 3 pages are fun and exciting,
Yeah.
and then you're like,
diagram.
what is going on? I don't understand it, and then there's still 800 pages left.
And what people don't realize, and I've had this conversation at a couple of events I went to for the MIT Society of Women Engineers, where I'm talking to juniors who are like, oh my god, I shouldn't be an engineer. This is awful, and I have to sit them down and say, engineering is a multi-year project. It's not something anyone's good at in the beginning. It's something that's incredibly painful to learn. It takes years to build intuition, and you are just going to suck at it for a couple of years. keep on going, you'll get over that transition, and then you'll feel good about doing engineering. And you get there by the end of your junior year.
One quickie, Waz, where you
It's
work,
hard.
is there an internship program, summer jobs for really cool people?
Yes,
and stuff?
we do have interns. I'm not entirely sure about how we go acquiring them.
Yeah.
You have to apply through the.
Yeah, I mean, I think if you go to the VEAS website and there are opportunities and there might be someone in HR you can contact if you're interested in an internship,
Yes.
I think they have that information up on the website.
Yeah.
That's how you do it.
Someone noted that the Horton Hill lab manual is great, and we have the student manual.
I like the student.
That's
The student
we like it
manual.
better than the book.
The student manual is actually quite good, and the student manual makes the rest of the book easy. But I think I just see so many people, and like this happens constantly. They're like, I want to learn engineering, electrical engineering. Can somebody suggest a book? Yes, you should use Horton Hill, which is like the standard book, and it's actually the worst book to learn
It's
from.
a cookbook.
It's a reference manual. It's
Yeah.
like, I want to learn English. Here's a dictionary.
Yeah.
It doesn't make any sense.
It's all the parts you need, but it's not everything you need.
It's just what you. It's excellent once you know everything. You can go back.
Yes.
And it's fantastic for that. But I think 6002 has the same issue. The fact is, it is the correct way to learn electrical engineering, and everyone who wants to be electrical engineer should take 6002. But the thing is, people who say they want to be electrical engineers do not want to. They actually just want to build stuff, and it would be better if they just built stuff. In my opinion.
Yeah. Okay,
We'll
we're gonna
see
go
what
a couple of minutes over, but
Okay.
Thank you.
No, wait,
That's the great questions. This is all really good.
But I'm the
It's
pessimist.
because
Waz is
we
the
care.
optimist.
We care.
Yeah.
I care.
I think people just want to use an Arduino. I don't think they want to do like transistor modeling.
But I mean, what if they feel really uncomfortable with like, I'm using this thing, but I don't know why it works? And then you want to, I mean, I became an engineer because I want to know why it works.
They're better off doing 6004 and 6002. Sorry, 6002 it's not real world applicable the same way.
Someone said something interesting that by starting out with this, they're basically weeding out a lot of people. So if you stick with this,
If you stick with this,
you can probably do
If you
anything.
stick with it, you actually deserve like
you really,
something.
yeah. I mean, that class sent me home in tears. But it was worth it in the
I
end.
passed it.
I
but
passed
that's all
barely.
I remember.
I did not get a good grade in that
That
class.
class is so
And now I do engineering for my job.
What do you think of the PE exam? Useful?
I haven't, so I don't get to work with, I don't work with PEs. So I thought about becoming a professional engineer, which is like a extra license certification.
PEs are not relevant to what we do.
No, they're not, because
PEs are
it's-
for civil engineers.
It's for civil engineering
and people who
and
work
for infrastructure and
government.
people who work
My uncle is
on
one.
major power systems and
Right.
things like that.
It's not for people who do lab work.
If you
or
work
research.
at semiconductors or research industries, there are no PEs that you can even apprentice to try to get hours, and you need that to qualify for taking the exam. So I've never
not.
taken the
It's
exam.
not for. It's the misuse of the word. Well, it's not misuse of the word engineer, but people don't understand that electrical engineers are engineers and civil engineers are engineers. But only civil engineers
usually
really need
become
to be
PE, yeah.
PEs. There are some EEPEs, but it's very, very rare from what I've seen. It's only
My friend Robot is an EEP,
it's only
but it's very he went on a mission.
it's only
to get
if you're
his
doing
PE.
like government work. Honestly, nobody else even asks or cares.
I mean, I'd be interested in looking at it. I've never
Look,
seen
get
the
air and
exam.
emissions insurance. And
I
you're
do
done.
want to read the ARRL handbook though.
That's totally different.
I know it's totally different,
should
but it's full of fun radio circuits.
It is, and you should get a radio license apparently, according
Okay.
to this guy.
Let's do the trivia question.
Okay, trivia question.
What do you want to give away? I know what I want to give away.
What are you gonna give away?
Let's give away a bento box.
Bento box kit.
Yeah.
You get a pack.
Arduino not included.
Arduino not included, but you know most people have an Arduino, so you just
Yeah.
toss one in.
And we'll have a cat friend here in a second.
Whoa!
All right.
It's a cat friend.
Here, it's going to be a super quick and easy one. The prize is this is going to be the prize. This is the bento box.
Arduino not included.
Yeah, Arduino not included. Here is the trivia question.
Okay.
What is the model number of the OtterBox that the bento box is? So if you've been watching and you know our site and you know the type of OtterBox we have. Hey, there we go. Someone got it right away. Vaya con queso.
Good job, Tycon Queso.
Is
Vaya
it?
con Dios is go with God, and
Via con
queso
queso,
is
go with cheese.
Yeah, if I pronounce that right. Please.
I thought it was like
Via con
Yeah.
queso.
No, I'm just talking about what I'm gonna have to eat
That
after
made
this.
sense.
Yeah, we don't have a winner. I'm just hungry. I saw God, and it was a goat with teeth. You won. Email support at adafruit.com.
it's a 3000 series.
Yeah.
3,000.
Okay,
All right, it's cat time.
unleash the animal.
Yeah. Okay.
Put him.
Yeah.
What's
Do you
it?
know how to
Look.
do this?
This is Becky's apprenticing for the
Part
professional
of
professional
Becky's,
cat.
Part of Becky's job is animal handling now.
I can't see what's happening.
It's pretty intense. Must fit.
Okay, let's
with,
see what's over
constipated.
here now.
We have a
This is-
constipated kitty.
This is an internship for sure.
Oh,
Yeah.
nice.
He's such a nice cat.
Yeah, part of working at Adafruit. Oh, he's a little scared. Part of working at Adafruit
He
is
doesn't understand
animal
why there's so
handling.
many people.
Why are there
Why
five
there's
people?
so many people.
He's so easygoing.
Do you think he needs some glands?
Did we decide if he was N channel or P channel?
No, he's an N channel
Oh.
because he only likes it when the source is above the drain. If you put the drain above the source, it's not good.
You're kidding me.
Right? Wasn't
No,
that
that's a
it?
P channel.
Oh, he's a P channel. I don't
P
know.
channel.
I can't always forget this.
Oh.
Very cute.
Oh.
You flip it upside down, you'll see. If you put the drain above the source, he doesn't like it.
He'll meow.
Yeah.
That's the meow of terror.
He'll be negatively biased.
Okay, let's see.
Yeah,
That's
so
it.
thank you.
So, Bento, it's a code for the rest of the night. This is going to be active until like tomorrow morning, so get your order in.
And you can pick up one of these fantastic Woz design kits.
Maybe you could talk about who's going to be on the show next week.
Next week is another special get music.
It's Jessica next
Sorry,
week.
next week
And then
we have
I have to-
another.
yeah.
We have two. We
They
have
have a
two
long
more people.
series.
We have a long
Lineup.
series. I just want to
Great
make sure.
lineup.
Next week we have Jessica from Parallax.
Yeah.
Jessica, what's her last name?
Bellman.
Bellman.
What?
Bellman.
Velman.
Yeah.
Yeah, we have Jessica Velman showing up.
And then after that, Aya will be little bits the week after.
Little bit. She's
Yeah.
actually in Soho. She's going to be coming down on the train, which is kind of handy. But Jessica's coming from all the way from California. Which is neat. And she's going to be talking about Parallax, and we're going to also talk about the awesome new robotics shield thing that for Arduino that combines the fantastic Parallax Bobot with the ease of use and happiness of an Arduino.
Yeah.
And hopefully we'll have them back in stock because we sold out in like 5 minutes.
Okay.
She just made a Tron bag.
Yeah, she just made
And she made a Tron bag.
following the-
And hopefully she'll bring it, and we'll be all like Troned out.
Special
And
thanks
then we
to
have-
our folks who showed up in the chat tonight,
Yep.
and all the show and tell folks. And Paint Your Drag was there, Freak Lab was there, John Junior was there, George for
Yay!
recording the show. Everybody doing a good job with the
Akiva
stuff here.
does such nice stuff.
Yes. Let's see.
Cat likes to be
And that's it.
Pet the cat.
poked.
Okay. Thank
You
you,
can
everybody.
poke the gate.
Here is your mom. You know, can I use the diodes like I sell them?
Yeah, your moment is well. That's
Here,
not a
Diode.
zero.
it's not a zero. Wow. I gotta do zero. Okay, here is your moment of Zener.